Hello, today we are going to be solving rational equations, which is going to include our knowledge of adding or subtracting rational equations and finding lowest common denominators. So we're going to start off with finding common denominators for each of the set pairs. Okay, very simple one. We're just working with numbers, so a common denominator. So common denominator here of 5 and 10. Well, we know that 5 goes into 10. So it'll just be 10. I'm not writing LCD because it doesn't have to be the lowest common denominator. It just makes things easier for us. Okay, the next one. Now we're including coefficients and variables, so numbers and variables. So we look at the numbers first. A common denominator between 3 and 4 is 12. And then the base will always be there if there is a base at all, and we'll always go by the highest exponent. So 12x squared is the common denominator here. Okay, moving on. Now we have a 4 over 1 and a 3x minus 5. 4 over 3x minus 5. Well, if this fraction is 1, then the common denominator will just be the other denominator, because 1 goes into everything. Okay, for this one here, we're getting a little bit trickier. We have a quadratic function as the first denominator, a linear function as the second denominator. So we need to try to factor the quadratic. It's a difference of squares. So it becomes 2 over x plus 1, x minus 1 to go along with our x plus 1. And then we see that the only difference between now the new first denominator and the second one is that the first denominator has an x minus 1. So the common denominators here are going to be the x plus 1 that's included in both of them and the x minus 1 from the first one. Okay, here again we need to factor. So this first one, simple factoring, factor is a 4, let's subtract a 3, we're going to end up with x plus 4, x minus 1. And then we have it looks like a backwards difference of squares. So we're going to take the negative, by taking negative out of it, I create the difference of squares that I want. So the denominator will become minus with x plus 1, x minus 1. Okay, so the common denominators, what they have different, well, there's a minus sign, like a minus 1 factor, so let's put that in. And then the first denominator has an x plus 4, x minus 1, so we know those are going to be included. But the second denominator also includes an x minus 1, so they cancel out, we don't need to write it again, so the only thing different is the x plus 1. Okay, and then here we end with, again, a linear and a quadratic, but you see the quadratic is not a difference of squares. It does not have a negative sign in between the x squared and the 6. There's not a b term, so it can't be factored any further. So the common denominator here is just going to be your factor of x minus 2 and x squared plus 6. Okay, let's work with an actual question here. Determine the point of intersection of the functions fx equals 2 over x squared minus 1 and gx equals x over x plus 1. So the point of intersection, so when do they equal each other? Well, let's start with our equations. 2x minus 1 equals x over x plus 1. So in order to solve, they have to be on the same side of the equal sign. So we're going to move them both to the left, and by moving that positive fraction, it becomes a subtraction question. Okay, now we're going to factor the first denominator because it's a difference of squares. So we get 2 over x plus 1 x minus 1 minus x over x plus 1. Right, that's going to give us our common denominator. So they both include x plus 1. One of them includes x minus 1. Okay, great. So we want both denominators to end up as x plus 1, x minus 1. Okay, we see the first fraction already had that denominator, so we don't need to change anything. Let's keep the 2 on top. But the second one, we added an x minus 1 bracket. So that means we need to multiply the second numerator by x plus 1. Sorry, x minus 1. Okay, and when we distribute, actually, let's just do everything step by step. So we're We're multiplying that in, we're going to distribute this, so what we're left with here is 2 minus, okay, x times x is x squared, x times negative 1 is negative x. When we do the actual adding or subtracting like the step we're at now, you can just make it one fraction with that common denominator. Okay, so let's move over here. And we're going to simplify the numerator, so we have a negative x squared. Okay, negative 1 times negative 1x is positive x and plus 2. Good. So now that everything's done with the numerator, right, we've distributed, we've collected our like terms. Because we're finding the point of intersection, we need an x value. And remember, the x values come from the numerator. So we don't actually even care about the denominator anymore. Actually, let's factor this out, and then we'll determine that. Okay, we don't like negative x squared, so let's take negative out of it, make it x squared minus 1x minus 2. Scrap what I said about not caring about the denominator yet. Okay, when we factor the numerator, we get x minus 2, x plus 1 over x plus 1, x minus 1. Okay, now it's simplified. We can see that we can cross off these x minus 1s, leaving us with negative of x minus 2 over x minus 1. Okay, now we only care about the numerator. We can see that the factor of the numerator is going to be positive 2. So that means these two equations are going to meet at 2. And I'm going to do the first one in red and the second one in blue. Okay, so when I plug 2 into the first one, I get 2 over 2 squared minus 1, which is 2 over 3. And if I do the same just to check with the other one, we get 2 over 2 plus 1 makes 2 over 3. Okay, this is just to check. You only have to do it once. You can pick and choose which of the two functions you want to plug your x into. But now that I did it with both, we saw that they got the same answer. We can conclude that the two equations have a point of intersection at 2 and 2/3.